Good afternoon, everybody. It's My name is Solis-Herrera. I am an ophthalmologist, and I wish to talk about a new method to remove CO2 from water. This method was developed based in the physiology of the human eye. If we want to stop the Earth from warming, it's clear that the coal, oil, and gas must remain on the ground. But CO2 must be removed from the atmosphere and water. What are the options? The world is on average 1.1 degrees Celsius today than in 1850. If this trend continues, our planet will be 2 or 3 degrees hotter by the end of this century. The main reason for this temperature rise is higher levels of atmospheric carbon dioxide, which cause the atmosphere to trap heat radiation from the Earth into space. This is directly related to the burning of fossil combustibles. So, the forest, the plankton and plants over a billion years stored CO2 and keep it out of the atmosphere. But fossil fuels are burned, so CO2 is released and back to atmosphere. CO2 hits the Earth, and atmospheric CO2 should remain at a minimum. One option is reforestation, but this requires of a great size of land areas. For instance, the size of the entire United States. Humus in the soil stores a lot of carbon, but this is being released through the industrialization of agriculture. The amount of humus in the soil can be increased by using catch crop and plants with deep roots, as well as by working harvest remnants back into the ground and avoiding deep plowing. Storing CO2 in the ground is already well known and practiced in Norway's oil fields. However, the process is still controversial, as storing CO2 underground can lead to earthquakes and leakage in the long term. Other method is CO2 is sequestered into porous basalt rock to be mineralized into stone. Both methods still require more research, however. Capturing CO2 to be held underground is done by using chemical process, which effectively extract the gas from the ambient air. This method is known as direct air capture and is already practiced in other parts of Europe. As there is no limit to the amount of CO2 that can be captured, it is considered to have great potential. However, the main disadvantage is the cost, currently around 550 or 2 pounds per ton. Another way to extract the CO2 from the air is by biomass. Plants grow and are burned in the power plant to produce electricity. CO2 is then extracted from the exhaust gas of the power plant and stored deep in the air. The big problem with this technology, known as bioenergy carbon capture and storage, is the huge amount of space required. CO2 is bound by rock minerals. Carbonate, silicate are mined, grown, and scattered on agricultural land or on the surface water of the ocean, where they collect CO2 over a period of years. According to researchers, by the middle of this century, it could be possible to capture 2 to 4 billion tons of CO2 every year using this technique. The main challenges are primarily the quantities of stone required. The idea is to use iron to fertilize the ocean, thereby increasing its nutrient content, which will allow plankton to grow stronger and capture more CO2. But carbon capture facilities are still very expensive and take up a huge amount of space. A novel method is based in the movement of water inside human eye. Since 1990, we are studying the movement of water inside the eye. It's interesting that the vitreous humor is 99% water, but turnover rate is so slow. Perhaps it's a total exchange 2 times during the lifespan of the individual. The vitreous body is the part of the human eye that fills the space in the center of the eye. It is the largest structure within the eye, yet our knowledge of its molecular composition, supramolecular organization, and physiology are perhaps less of any other parts of the eye. Vitreous is viscous, colorless, and clear, and is composed mainly of water, more than 95%, glucose, inorganic salts, hyaluronic acid, type 2 collagen fibers, and ascorbic acid. It is acellular and relatively isolated, rendering it less susceptible than blood to biochemical change, bacterial degradation, and contamination. More than 95% of the eye is water. But the cellular function depends on the regulation of the composition of interstitial fluid, body internal environment, and composition of interstitial fluid change as it moves. Movement back and forth across capillary walls provide nutrients, glucose, oxygen, ions to tissue cells and removes waste. However, the vitreous body has not blood vessels. Therefore, how is maintained the low levels of CO2 and higher levels of dissolved oxygen inside vitreous body? Because retinal tissue that form an envelope around vitreous has the highest metabolic index of human body. It's very interesting. When CO2 levels increase within vitreous body or dissolved oxygen levels decrease, vitreous body becomes turbid, losing its transparency, thereby there is a vision loss. Restoring CO2 and O2 levels, the vitreous body regains transparency and thereby a function improves. It took us 12 years and 6,000 patients to understand how CO2 and O2 levels are keeping within physiological values inside the vitreous body. And from 2002 to 2007 to replicate the human eye process in the laboratory. The blocks inside the flask release oxygen in the same way that the oxygen is released inside the human eye. Look, there is no turbulence, and the oxygen travels from the bottom of the flask to the surface. So it is enough to put these kind of blocks in the bottom of the river, of the lake, of the sea, and this release of oxygen begin and during years and years in the same way that happened in the human eye. For instance, this is a fishery that tried to inject oxygen, air more exactly, and there is a lot of turbulence, and the air, mainly nitrogen, return to atmosphere almost immediately, and our model is more efficient. 84% is oxygen. There is no turbulence. There is a northern light happened inside the eye, and it's the same method that nature uses. We are replicate the experiment hundreds of times. The results are very consistent, and usually dissolved oxygen levels in any kind of water increase significantly, usually more of 6 milligrams per liter. And we are test in laboratory drinking water, seawater, wastewater, and in every kind of water the process occurs. And the pH values tend to improve also, depending of initial values and pollution content. but always there is a trend to a pH value to improve. It's enough to submerge the block of ore material weighing between 8 and 10 kilograms and let it reach the bottom of the body of water to be treated. Dissolved oxygen levels begin to change within a few days. The half-life of our blocks is 20 years or more, like inside the human eye. So it's enough to leave the block, its submerged to reach the bottom of the body water, and the bubbles begin to be released and travel to the surface. But during the travel, the oxygen bubbles are captured by many microorganisms, many chemical reactions, many processes, and finally the pH of the water improves, and dissolved oxygen levels improves. So this is all for today. If you wish more information, please contact us through these emails. Thanks for your attention. Bye-bye.